This puts a lot of the log stuff, exponential stuff, and like algebra 2 kind of all in one question. So let's go ahead and try this first one. We're not going to do all of them that I have up here, but at least we're going to walk through some of them. Give me a second to write that one down if you want to. So what first thing is going to be what strategy are we going to take for this one? Yes. Combine them and then change it to exponential, right? So let's combine them first. It's addition, so we got to multiply when we bring them together. Log 6 of x plus 4 times x plus 3 equals 1. Now we haven't had one like this where we're multiplying two of these binomials. What do we do when we have that? Yeah, distribute it, which what is it called? Foiling, right? First, outer, inner, last. Right, remember that? So then we get log 6. Our first terms give us x squared. I'm going to go ahead and combine the outer and my inner because it'd be 3x and 4x. Right, 3x and 4x gives you 7x in the middle, just to save us from writing it again. And then 4 times 3 is 12. Plus 12 equals 1. So we FOIL that out. Okay, now at this step, a lot of people have been like, just this step, just setting these two things equal, ignoring this. You can't do that though. You gotta take this base, raise it to this power, so 6 to the power of 1 equals then all of this stuff inside. X squared plus 7x plus 1. Now from there, whenever you see three terms with like x squared and x and then a number, we want to combine them and set equal to 0. So we then subtract this thing over, right up here. X squared plus 7x minus that 6, so we can just plus 6 equals 0. Okay. And then it's an easy factoring. We just think what multiplies give you 6, add to 7. What do those do? Yeah, 1, 1, 6, x plus 6, x plus 1. And then we solve these two, 7 equals 0, so we get x equals negative 6, and x equals negative 1. Okay, so now another thing that we've always said is like generally if you get a negative, then you cross it out. Well, this one, we have two negatives. Are these both not solutions? Why not? Which one is a solution and why? Right, yeah. So we both said, yeah, negative 1 actually works. Because if you plug it in, which is what we want to do, this is negative 1 plus 4 is a positive 3. Now give us a positive 2. So this one's okay. Even though it's a negative number, it'll work. That one doesn't because it will give you negative inside the logs. So the way you check is just plug it back into the original and make sure you only get positives in your logs. Right? We're not going to do this one. It's very similar to this. It's just what would you do first to start this question? You can't cancel them because there's this here. Yeah, we want to add it over to this side, just move it around. And again, I'm not going to do this whole problem. Just wanted to show you because it's very similar. And if you add it over like this instead of equal to 1, then we have this scenario, right? So then we can multiply them, and you're going to get a very similar answer. Don't want to take the time to do that, but so that one we would just need to rearrange. Let's look at some more here. I want to show you this natural log one. And the natural log one that's on your assignment is pretty hard. They're hard because they have ease with them. But we'll just do our best. I always want you to see how you could go about doing this. So natural logs are just logarithms, right? Remember, they're just a special logarithm. They're a log-based ease. So we can combine them in the same way, use the same properties. Here it looks like we want to combine them right and then use exponential form. So combine these two together, we would get the natural log of x plus 1 over x equals 2. Okay, so now at this point we would want to take it to exponential form. So we would always do whatever this base is raised to this equals this. This base is e, because if you remember it's log e, that's what natural log is. Right? So how you would actually have to write this is e squared, this is a visible e there, e to the second power equals x plus 1 over x. And now you got like, now it looks like another variable, you got a e squared here, that doesn't look really that great. This is just a number though, it's just a number. So to then solve this, sort of gets a little confusing. Generally you don't want variables in denominators, so we'll just multiply it over. Okay. So we get e squared x equals x plus 1. Now I'll show you two different ways of doing this, and I'm okay if you do either one. One strategy would just go ahead and find what e squared is. E squared is just it's going to be a number, 7.389. So we'll just go ahead and make this 7.389x equals x plus 1, if you want to do it that way. We would then just combine our x's, so we're going to subtract an x, so just minus 1x over here. So minus 1 from there, let's get 6.389. X equals 1. And then to get the x by itself, we would then divide. So this is a 1x. It's like we have 7 x's and minus 1x. Oh, 6 x's. Yeah, that's a bit confusing. So then we would divide 1 divided by that. And you get a decimal, right? So it's not a great answer. This is not actually the answer you would see in the book, though, if you look at it. I'll show you the other way, the actual best math answer. Well, so this is correct. If you plugged in a calculator, we would get exactly 2 because this is rounded. But this would be an okay answer. The other way to do this, if you're going to take calculus at some point, anybody going to plan to take calculus at college or anything like that? Maybe if you're engineering or anything like that. So how you would want to write this, like this is the best way to write it, is at this step here, you want to group all your x's together. So we'd actually subtract this x over. Remember, this is e squared x minus x equals 1. Okay. And then what you would do is you'd pull out the greatest common factor. These both share an x, so you'd pull out an x. You'd be left with x times e squared minus 1 and 1. And then you would divide by e squared minus 1. So x would be 1 over e squared minus 1. And that would be your answer. That's the most exact answer. And if you actually did that on a calculator too, you would get a very similar answer to what we just got. .1565, yeah, same answer. This is just the exact answer, but I'm okay if you don't do that. You don't stick with this, but if you want to try that, I'll go for it. The natural log one that you actually have to do for your problems, unfortunately, is a quadratic formula one. So I'll just have you try your best on it. All right, I want to do the next one here. And this one also is going to end up being a quadratic formula problem, which is something that you should be good at. You might not be, but you should have done a lot in Algebra 2. Tedious, yeah. It's a little bit tedious. But you'll have to do one problem with it. So, do everybody remember how to do that? Quadratic formula? Negative b plus or minus square root of b squared minus 4c. Did I do that? Alright, well, we'll do one here. Alright, so let's go ahead and tackle this one. The setup's going to be the same as the one where we multiply them. And let's see what we get here. So we got addition, which means we want to multiply log 2. And it's going to be x plus 1 times x plus 7 equals 3. And let's skip one of the steps here. Now we're going to put an exponential, so it's going to be 2 to the third equals this, right? So 2 to the third equals this. And let's go ahead and multiply it. So we get x squared, and then we get x, 7x, so we get 8x. 7, right? So it's just foiling that out. All right, now what we would then do is want to take this over, right? This is the same thing as 8. 2 cubed is 8. So we subtract 8 over. And what we get would be x squared plus 8x minus 1 equals 0. Right? So the problem here is we want to try to factor this. So you got to think of factors of -1 that give you 8 when you add it together. It's not possible, right? The factors of 1 are 1 and 1. So how are you going to get 8 out of that? Well, there is a way you can solve it. It's just not by factoring. When you encounter this, then you have to use the little quadratic formula. The other classes would just say it's no solution all day. But there is a solution. Let's see if we can remember it. I'm going to erase some of this stuff here. Alright, so here's the quadratic formula. I'm sure you had to memorize that at some point. Unless you, I guess, took this during online quarantine school or whatever. I don't know. But I guess maybe there's no way that forced to memorize it. Did you guys have to memorize this last year? Okay. Good. All right. So this is something you should, at least be familiar with using, right? So here it is, and we know this is our A, this is our B, this is our C. Let's go ahead and do it. X equals -8 plus or minus the square root of 8 squared minus 4 times 1 times -1 all over 2 times 1. Alright, simplify this, we get -8 plus or minus. Inside here we have 64, and this is going to become a plus 4. Multiply those. 64 plus 4, so it becomes 68 over 2. Now at this point, you have two options. One is to then just go ahead and find the decimals at this point, if you want to go ahead and do that. -8 plus the square root of 68 divided by 2. So we get x equals 0.123. And then do the same, -8 minus the square root of 68 divided by 2. And you get -8.123. So that's one option. We then need to look and see if these work. This one works, right? Plugging in both. This does not. You get a negative. So this would be, if you want to write your answer like that, I'm okay with that. You should, at some point, have actually simplified this, though. You guys simplify those radicals. Never doing that. This is the right way to do it. This is okay, it's an estimation, but the right way is then to simplify this radical. This is the same thing as 4 times 17. Okay, so it's 4 times 17, right? So you can pull the 4 out and write this as 2 radical 17. So then this would be x equals -8 plus or minus 2 radical 17 over 2. And then you could do one better. You could then, now since all of these have a factor of 2, you could then write this as -4. And then let's just do the plus one because that's the one that works. Plus, these would cancel and this one changes to a 4. You just divide both of these terms. So then there's -4 plus radical 17. And if you look up the answer for that, that's what you would see. -4 plus the square root of 17. But I'm okay if you want to just type in the decimal, show at least to this step and then the decimal. But if you want to be more exact and you feel comfortable simplifying radicals, go ahead and try that other one there. Let's do just like one or two more here. Maybe just one more. Yeah. And you'll figure the other ones out as you go. Let's try this last one. So this one looks kind of crazy, right? If you had seen this problem maybe a year ago or something, you would think, well, how am I supposed to solve something with all these words in it, right? And this one actually is pretty easy to solve if you know some log properties. Let's think about our strategy first before we tackle it. What do you guys think our strategy is going to be here?
I'd probably add some utilities so we can find somebody.
Okay. So you're going to switch spots?
Yeah.
Okay, I guess you could do that. Yeah. So then, like after that, what would be your what do you think long term can happen?
I think you would take the numbers in common.
Okay, yeah, take the numbers, these two, make them exponents. Okay, good. All right, yeah. So then we'll be able to combine these, right? And then we should be able to cancel the logs because there's no other numbers outside of just the log terms. So we should be able to combine this. If you wanted to swap them, I suppose you could. But then it'll just be a log 3 of something, a log 3 of something we just said. Right. Right. So let's go ahead and combine them. And like I said, if you wanted to swap them, you could do that. I'm not going to do that, but that would be fine. This goes up here, and this one goes up here. Now you don't have to take the negative with it. You can leave the negative there. It just means subtraction. So we got log 3. And then subtraction means division, so it's going to be x, so a little space, x over 5 squared, or just 25, right? So this term over this term. Okay, equals log 3, and then this goes away. This is just 100, right? X plus 1. Okay, so now we got two log terms, and we can set the insides equal. So we'll set x over 25 equals x plus 1 over 100. Now what from here? So we'll multiply both sides by 25 and also both sides by 100. Right, so it essentially just becomes cross multiplying. Maybe the easiest way. This becomes 100x equals 25. So make sure when you multiply this, you do times x plus 1 more, not just times x. So then we get 100x equals 25x plus 25. And then subtract the 25 to get 75x equals 25. Divide 1/3. Yeah, 1/3. Next. So really that wasn't bad, right? Once you just did the log properties. And then it's just some basic algebra. So the plan for the rest of today, and then also I'm going to give you some time tomorrow to work on this. You don't have to do this for homework. This is just going to be classwork. Call it. It's a little bit easier before break here. And some of these are pretty challenging problems. You'll probably get stuck at some point, and you'll need to ask, how do I solve this from here? So I want you to work through those. Again, there's some that are pretty challenging, especially the natural log one. You have to actually use the quadratic formula with E. So just do your best, and if you get stuck, like I said, raise your hand, ask me, or if someone else around you has already done